So today I just wanted to run through some super basic um, Python scripts and Python programming beginner's guide, I guess. This is more for me. I'm just going to record this clip and save it for my own learning. So Python programming. What is great about Python? What's bad about Python? Why would you learn it over C#, C++, Elixir, JavaScript, any of the other common coding languages? So, great thing about Python, I think, is syntactically simple. Quite easy to read the code. That's what syntactically simple means. The types are quite specific, and there's a lot less code writing than in something like C++ or C#, where there's a lot of syntactic sugar, which basically just means extra things that you have to think about as you go. So that makes Python a great first language to learn. I've been trying to learn it myself over the last couple of years, and basically just improve my skills because it's a really handy tool to have in your arsenal. So let's start with some basic Python data types. So ints, integers. What is an integer? Integer basically is the same in most programming language, if not all programming languages. All it means is that it's a whole number. So int type is something like 55, 7, 8, 4, 2, or it can even be huge numbers in the millions because these are whole numbers and they're not fractional. There's no floating points, so it's not like 2.6. It's just a whole number. That means it's an int. Super simple to understand. I think you could all agree. So integers are used loads, especially in day-to-day basic stuff in Python. I use them a lot when doing data science type things with Jupyter notebooks. So the next like numerical data type is a float. And a float is basically the same as an int, but it has a floating point. So 1.5, 76.9, whoops, or this, whatever the hell that is. These are all floats. Floats are obviously more specific than just using an int. Sometimes you might need an output or an input into a program of 2.5. So this would throw an error if it was an int, but if it was a float, it would make sense to the program. Quite simple to understand, super basic. So things like lists. So if you want to do a list in Python, also very nice and easy. Say you have a list of colors, your favorite colors. So we would call this color list. Color list could be a list of your favorite colors. So let's say red. Oh, keybinds. Green. And blue. RGB. So the square brackets in Python, that denotes that it's a list. It could be a list of anything you want, any kind of item. And the things within the list, because they're in double quotation marks, these words, if you like, are called strings. And I think it's basically the same in all programming languages. strings, it's just a string of text. So that could be hello, or any kind of random word you want. And strings are denoted by these double quotation marks. So the code reads it as just a string of text, and this is the data type that's input into the program. So that is a string, because they're in double quotes. You can also, I think in Python, you can also use single quotation marks. And I think that works as well. But if you are doing that, you want to keep it consistent throughout the whole code base. Because if you're mixing single quotation marks with double, it can become a problem later down the line, because it can kind of confuse the program a little bit. But I usually stick with double quotation marks when doing strings. And strings are kind of like ints. They're one of the most simple data types within Python and within most programming languages. Python is super awesome because the syntax is so simple. You can just, you want to put in a string, you just put your double quotes and whatever text you want in between. With C and C++, there's a lot more that goes into it. So we're not going to go into that in this clip. We will just keep it super simple for now. So what else can I talk about that's super simple about Python? For loops and while loops. So what is a loop, first of all? So a loop is a piece of code that iterates through something. So take this list, this color list that we've created. A for loop will run through each item in the list. So it will run through red, green, and blue. What is the point of that? What is useful about that? What is cool about that? So if we wanted to print our color list, so this is our task. This is what we want to do. We want to print out our color list. In Python, printing is super simple, and all print means is that the output is displayed to the screen on the command line in Python. You can do a lot of other things later on with the print function. You can display data visually in certain ways, and it's just a very useful tool. It's also useful for debugging when you've got quite a lot of code and you don't know whereabouts the error is exactly. It can be super confusing. So we use print. It's not the best idea in the world, but it's quite quick and easy. You can use the print function to figure out where the code got to. So you can print here, print here, print here, print here. And if, when it prints out, you'll see here is where the code reached, meaning this is an error, or whatever line after the print function actually displays was where the problem was. So that's super useful. Anyway, so this is how you print something in Python. Literally use the word print, open your curly brackets, and what did we want to print? Our call list, right? We save this, see what happens, run the code. There we go. There is our color list. Nice and simple, but super cool. Because this can be used for loads of interesting stuff as you get more and more skilled with programming. Now, I think you can basically also print strings. So if you print hello in the code, print our string hello. And if you do it integer, do it again with a floating point number. You remember this kind of thing. Print 555.5. Save that, run the code. And there you go. You can basically print out whatever you want within reason. So let's talk about loops. Get rid of that. So what the hell is a loop? Like I said before, loops are used to basically loop through something, meaning it will go through each item. It doesn't have to be a list, it could just be a string of numbers, a string of data. It could be a dictionary or whatever data type you're using. And a loop will run through it, loop through it, and then you can do whatever you want with it. You can print it out, you can basically edit the data, you can modify it, or do what you want, which is really cool. So let's make another list, shall we? Let's do number list. And we're doing exactly the same here. So this is the name of the list. Equals square brackets, right? Because it's a list. And we're going to do, let's do integers, right? Whole numbers. 5, 6, 2, 150. Just random numbers picked from thin air. So I want my code basically to run through these numbers. 5, 6, 2, 150. So what I would do is I would use the keyword for, and this is what's called a for loop. So click for loop example. Loops are used constantly through programming and very much a useful tool to know and a useful tool to have, especially in Python. So for loop. So what we need to do is we type for, because this is going to be a for loop, and then we need to specify a name for each item within the list. So technically this could be whatever you want it to be, but because it's a number list, I would recommend doing for number, and then we use the keyword in. So it's meaning for number, for item basically, in, and where are we searching? We're searching on number list, right? The for number in number list. So this line, it isn't finished. As you can see, we've got the squiggly red line, which tells you there's an error. It expected a colon at the end, okay? And I'll move on to that in a second. But this line basically is the for loop, the first part of it anyway. For number in number list. So that means loop through every single item that we've just decided to call number in where does the code need to look? It needs to look in number list. For number in number list, colon. And as you can see, I basically put the colon, press enter, and it automatically gives me the correct spacing. There's a gap here, see? And that's important. And my editor, my code editor that I'm writing this in is Visual Studio Code. Fantastic bit of software. This is basically extremely popular throughout the programming community. It's used in professional environments every single day, and it's my favorite code editor because you can basically change the look of it, the style, and everything. I like it because I've got this darker theme. The light theme really hurts my eyes, so I like this. It's a lot cooler. And you can also change the icons. See the Python here? You can change them. There's like hundreds and hundreds of different combinations, which is super cool. So anyway, carry on with our for loop, shall we? For number in number list. What do we want to do in this example? So the easiest example would be print each item sequentially. So print 5, 6, 2, 150, which if you remember, they're all integers, right? Because they're whole numbers. There's no decimal point. It's just whole numbers in this list. Because this keeps it nice and simple. And it doesn't complicate things. Now you can mix data types, but I'll move on to that afterwards. I just want to keep it really simple for this example. So, for number in number list, right? Let's print, like we do here. We want to print out each individual integer value. And it's iterating through the list one by one sequentially. So this is like the easiest version of doing it. So it should print 5, 6 to 150 integer values sequentially. So if we do print number, let's see what happens. So you can see 5, 6 to 150 sequentially printed out, which is exactly what we wanted to happen. That's really cool. So we're using the print function within a for loop, and the for loop is iterating through a list type, which is awesome because you can do some super cool stuff with this later on. So let's do a challenge. What if we wanted to print out all the items, so all the numbers within our number list, all the integer values that were less than 99? Right, so that should, in theory, print 562, skip this, and 50. Now, in Python, we have the less than, we have the equal to, and the more than signs. So, we can do a less than symbol first. So it's quite simply this backwards arrow. That means less than. And it's the same, it's a mathematical operator used in mathematics, and it's basically carried over into programming because it's simple to understand, quite logical, and it makes sense. So you can do things like 5 is less than 10, or 10 is more than 5. And the equal to sign, the way you do this is you can basically assign a variable, which I'll move on to next. So we could do a equal to 7. And what we're doing here, I'll move on to this next actually, but this is a variable, and you're storing the value of 7 in a. So why would you want to do that? Why is it even useful? When you're dealing with huge numbers, like multiple millions and millions of numbers, it's easier to assign them to something simple to understand, like a letter, like a name. So you could do big number, which is our variable name, equals this. And that, even though it looks crazy, still works. We're assigning this huge number, whatever that is, 723 trillion or something crazy, now has the big number word, the variable name, now has this value, this huge number. So if you want to reference this number later on in the code, you don't have to type the number out each time. You can simply do big number, and then you're basically referencing this, which is linked to this. So that is super cool. Now I'll carry on with variables in a second. So let me just comment some of this out. So less than and more than. Easy to understand. Pretty straightforward. I don't think I need to talk too much about this. So the equal to sign. So in Python and in JavaScript as well, I think. It might actually be different in JavaScript, but in a lot of programming languages, the equal sign means different things. So one equal sign means something different to two equal signs. And we're working in Python right now, so Python only uses up to 2 equal signs. But in JavaScript, they actually have 3 equal signs. which looks kind of crazy. But for now, we stick to these. So what do they do? What do they represent? The 1 equal sign is basically a you're applying the value. So the best way I can explain it is 5. I'll do it with a string actually. So dog equals brown. So we are basically applying this value to dog, like we did with the variable. It's exactly the same. So you can also mix numbers, which is kind of confusing, but it can be done. 55 equals 10. But this won't work because it can't assign the expression cannot be assigned. I'll need to put more code around this to make it work. So the double equals sign. So this is basically just an assignee operator. So the single equals, you're assigning values. This equals this, x equals y, y equals z, etc, etc. Now the double equals sign, like this, is used quite a lot, and it's used for basically comparing value. So it's used a lot in if statements, which I can move on to later. The double equals sign basically means if 5 is exactly the same as 5, do something. So in this example, right, 5, what is it? It's a whole number, right? So it's an integer. If 5 is equal, meaning the values, it is the exact same. So we're not assigning a new value. We're not saying 5 is 5. We're saying 5 is exactly the same in type, in data structure, in everything. It's exactly the same as 5. Do something. So you can basically nestle this within conditional statements, which is also really, really cool. Just say this. So we could do an if statement, and an if statement basically tells the code to compare the value of two things that you assign. If 5 equal 5, print, and we'll print out a string so we know if this has worked, right? If 5 is exactly the same as 5. Yes, 5 is exactly the same as 5. Run the code. There we go. 5 is exactly the same as 5 because the values are exactly the same. So let's break this code, right? Let's do an error on purpose so you can see the difference. If 5 equal 6, we will print no. 5 is not exactly equal to 6. Ah, yes, exactly. Why isn't this working? So, it isn't working because 5 is not exactly equal to 6. So this brings me on to my next lesson, if you like. If statements are only one side of the argument, right? You're just comparing things. If x equal y, do something, right? So what do we need? We need an else statement under this. So if 5 equals 6, so it's not printing, right? Because it doesn't actually equal 6. So this is false. Because the code will read an if statement or any conditional statement as two things, false or true. It's quite simple once you get your head around it, even though the syntax can be quite confusing at the beginning. If 5 equals 6, which we know it doesn't because it's not working when we run our code, print 5 is not exactly no, 5 is not exactly equal to 6. else, which means if this is true, do this. If it isn't true, else print, why is that throwing an error? Hang on. There we go. So, if 5 equals 6, print, I need to change this for it to make sense. Yes, 5 is equal to 6. And they're both whole numbers, so they're both the same data type. The only difference, as you can tell, obviously, is the value. 6 is one more than 5. So, if 5 equals 6, print, yes, 5 is equal to 6. Else, so if not true, basically, print 5 is not equal to 6. And there we go. 5 is not equal to 6. Because obviously, it isn't. Pretty cool. So as you can imagine, if statements and conditional statements in general are very, very handy. And you'll be using them every single day when learning programming. It's just something that we have to do. So let me move this down. So these are conditionals, right? So another cool thing, sorry, that's conditionals. Another cool thing about the assignee operators is exclamation marks, right? What the hell does this do? Because it looks strange, especially when you're looking at code. So what this basically means is not. It means not. So you can do cool things with this, such as, let's do another if statement, okay? Another conditional. So let's do if 100 is not equal to 50, we will print 100 is not, sorry, I'll do it like this so it's easy to understand, is not equal to 50. Now this should work, right? If 100 is not equal to 50, print 100 is not equal to 50. There we go. Now this is printed above this line because Python reads code from top to bottom. Because it's not a compiled language like C# or C++ or some of the others. Compiled languages basically read the code all at once, but Python reads it line by line, which has benefits, but it also has some negatives as well. I can explain them in a further video. Don't want to get too complicated in this one, and I'm still learning myself with Python, so this is more for me just to train my skills a little bit. So if 100 is not equal to 50, you print the string 100 is not equal to 50. So as you can tell, the exclamation point being not is very handy as well. So let's move on. Right, let's do some variables. Okay, so variables, like I said, all they are doing is assigning a value. So we can do x equals 50. The value of x is now 50. So what does that mean? It's hard to understand because x is obviously a letter and 50 is obviously an integer, right? A whole number. And letters are called chars in Python, which literally means character, which makes sense when you think about it. But when you see the word chars in code, it can be kind of confusing at first. But yeah, a single letter is basically a char. But this is a variable, right? Because yeah, it's a character. We've assigned it a value. So the value of x is now 50. Pretty cool. So what happens if we try to print x? Will it work? Will it print the char x? Or will it print the integer 50? Well, we've assigned the value to x as 50, right? So what do you think? Print x. Because we're printing a variable, obviously being x, we don't want the quotation marks. Because if we have the quotation marks, I'll show you what can happen. Oh, sorry about that. There's that. Right. Print x. What's going to happen? Have a look. X. Because we put it in the double quotes, as I explained at the very beginning, up here, it's a string, right? It's a string value. But in this block of code, this example, we don't want x to be a string, do we? It's a variable because it has a value assigned. And you can't assign another value to a string when you're printing it out as a string. So we want to just do simply x. Exactly the way it's written here, not a capital, like this. You want it exactly the way the variable is. Okay, so this should print 50, which is pretty cool. Because now the code knows that our value of x is 50. So what we can do more cool stuff with this as well. So this is a great little learning exercise. So we could do an if statement that mentions a variable, right? So if x equal 100, print. Now have a look. Nothing prints out, right? Let's try 50. There we go. So as you can see, when we did 100, it doesn't print, it doesn't work, because we've assigned the value of 50 to our variable. And in this if statement, we are basically telling the code if x is exactly the same, right? Double equal sign, not single. If x is exactly the same as 100, the variable, the integer 100, it's a whole number. We want to print the string. X is exactly the same as 100. And then we can throw an else statement in, right? Else, we will print x is not equal to 100. And there we go. Super cool. So this obviously is a variable again that we did, big number, and we're just assigning a huge integer value. So another thing we could do, right? We'll do another if statement. We'll do if x is less than 60, we can print a string x is less than 60. There we go. So we're using the less than sign, and obviously the value of our variable x has not changed, it's still 50. So this is true. This is false. This comes as true. Basically it prints out as true. And true or false in programming is basically known as a Boolean. You'll often see it just written as bool, B-O-O-L. Sounds kind of funny, but all it basically means is true or false. And that's kind of what conditionals do as well. But Booleans are kind of like variables, so you assign a value to them. And that value can either be one or two things, true or false. But these variables obviously are a bit more complex because you can assign pretty much any type of value that you want, which is very useful. Booleans are basically used when you want to be extremely specific with your code, and you only want an output to be one of two things, true or false. But I won't go too much into Booleans today because they can be quite complex once you get further down the line. So, what else can I move on to quickly before ending? Have a look. Right, okay. So this was our for loop, which iterates through the whole number list and prints out each number sequentially. Let's do a slightly more complex version of this, but I'll use some of these. We can use a less than sign, a more than, or a not. So let me have a look. So let's do a new list. What shall we do? We'll do an integer list, right? So we'll do whole numbers again. We'll call it int list equals. But if I leave it like this, the value int list is a list. So the code already knows that it's a list. That's why I've got no red errors, little squiggle lines under this. Like this here, these lines, okay? So, what can we do here? Int list. We're obviously going to include integers, so we'll do 55, 60, 602. I'm just typing in random numbers here, you don't need to follow along. And we'll do a big number, and then a small one. There we go, we've got 6 values, all varying massively in size. So we've got 4, 12,000, etc. So, what we can do here is, we'll do a for loop, right? For int, meaning for integers, because I can't reuse that word number or number in number list, because it could throw an error and confuse the code. So I'll just do it fresh here. For int in where? Int list, right? The name of the list that we want to iterate through. So for int in int list. So we know what this will do, right? It's a for loop. It's going to iterate through each and every number one by one. The for ints in int list, what we can do is if, so we're nestling an if statement within a for loop, right? Seems kind of crazy, quite complicated, especially for a beginner like myself, but it will make sense. So for ints in int list, if ints are less than or equal to, so as you can see, less than and equal can be used together. Also more than or equal to. So in your head, when you read this code out, you want to break them up. So if int is less than or equal to, that's basically the way you want to read the code, even though it isn't written out like that. That's the best way to get your head around it. If ints are less than or equal to, we do this, less than or equal to, let's say, what number shall we give? Give a small number, 10, right? Print int. So this will print out, it will loop throughout the list, obviously, iterate through for int in int list. The for loop will read each line, each value, sorry, sequentially. And then it will run the if statement. If the numbers are less than or equal to 10, another integer value, right, whole number, we'll print int. So this will print out every number within our integer list that is less than or equal to 10. And there's only one number here that's less than or equal to 10. That's why I did a small number, so it's easy to understand. 4, right? 4 is less than 10. And less than or equal to obviously means smaller than 10 or 10. So 11, it wouldn't print out, right? But 10, it would. So if I got rid of the equal sign, and I save that and run the code again, it will still print out 4. But the equal sign basically allows you to be more specific when you want to check if something is more than, less than, not, or same as, right, equal to 10. But if I do this and add another number in here, let's add 10. There we go. Because I've got the equal sign, 10 and 4 will print out. If I take away the equal sign, save the code, run it again, only 4 will print out, right? Because 10 is seen as less than 10. It's not, it is 10, so it's not, it's only numbers that are less than 10 being displayed here that we're printing out. But once I do the equal sign, there we go, 4, 10. So it will display both. Super cool. And obviously I could put this number as, let's say, 500. And it shouldn't make any difference. So this will print out. Sorry, less than 500. 55, 393, 4, and 10. Let's double check. 55, 393, 4, and 10. Pretty cool. So this is quite complicated for a first little video live stream, but it's super useful. And once you get your head around the syntax, how it all works, it makes sense. It's quite logical. So you can also, like I said, you can pass any type of data that you want into a list. It could be names, like we did color list. It can be strings. Where's our color list? There we go. So that's red, green, and blue. It can be integers, or it can be floats, right? Floating point numbers as well. And you can also mix data types, but that gets a bit more complicated. So that's it for now. Thank you for watching. On the next one, I'll carry on with this, but I'll move into some more complex techniques, other data types that we can do. I think I can explain some variable assignments as well, and some functions which are super, super useful. So thank you for watching. Goodbye.